So what I'm going to do today is I'm going to show you how you can use video to figure out the momentums and the effects of collisions between two different objects. So you guys should remember that momentum is equal to the mass times the velocity. And we abbreviate that with the letter P for some strange reason. So what we're going to want to do is have two objects, and we want to know their mass, and we want to calculate their velocities, and then see how their momentums change after the collision, and see if actually we can say that it's true that momentum is conserved, that no momentum is added or subtracted to a system. Now, of course, we live in the real world, and so after a collision, there's going to be a loss of some of the momentum and some of the kinetic energy in relation because of friction. When they crash into each other, there's some energy that's lost and it becomes heat. Not only that, there's some sound energy produced. The plastic or the materials that are being collided will deform a little bit. That uses up some of your energy. So it's not that you'll get perfect numbers, but hopefully we'll be able to calculate that as well. So what I've done here is I've made a video of myself smashing some cars together. So you can see I've got a car here, and I've got another car here that has some extra weights on it, half a kilo of extra weights. So I'm going to run this video, and just like you did with the ball, I'm going to chart the motion of each one and see how they react after they crash. Okay, so this will be a little bit of a process, but I think you'll get the point. Okay, so the first thing we have to do, and you can see I've already done it, is scale the video. So the video needs to know how big things are. So what I did was I just got the cars. Let's just get a car in line here, and I measured the car, and I know that the car is equal to 16 centimeters in length. So I can just draw that length here, and then I could tell it that it's 0.16 meters in length for each car. And what that does is that gives the program a sense of when something moves, how far it moved. The other thing I did is that I set the axis. So on this button here, I set the axis, and I'm gonna move the video so that the things are just off screen, like so. And I'm gonna set my axis so that it's going to make life easy for me. So I'm going to put it like right there at the front of the car. You could also choose to do it here at the wheel or any other recognizable landmark that'll make it easy for you. Okay? All right. Now, I'm going to do my little dot. So let's chart this one first. So I'm going to do the little dot thing, and I'm going to just choose like this top front corner of the car, and I'm going to chart that one all the way as it goes. So I'm going to go click, it moves, click, click, click. And don't panic too much if the dots look to be slightly different distances apart. We're going to get an average anyway, and that will help. And I click it all the way through. All right, now they're going to hit each other. Boom. Now they kind of stay still for that moment, and then it starts going backwards. And I chart it all the way back. All right. You don't have to do it that many times, but just once you get the hang of it, you can go pretty fast. Okay. So there I've got my first one. Now you can see on this side that it's charting actually the distances in meters, and these are like 0.05 would be 5 centimeters. So you can see that it's gone up and it's gone down, and you can't really tell that much difference between them. But what I want to do first is I want to change the y-axis here. I forgot to mention that if it's easier for you when you're doing your video, you can stretch this out so it's bigger. It might make it a little bit easier. And then you could do Command R just to get it to tuck away into a nice, neat place. But let's change this axis, and I'm going to make that x velocity because this is the velocity in this direction, this being the positive direction, right? And what you can see, the result there is pretty good. you see that there is a velocity here, then boom, and a velocity here. See that? Here's time, and there's velocity in meters per second. So let's figure out the first velocity. So I'm just going to drag across all these guys here, and don't worry about too much about which ones. And then this is the statistics button. You click that, and it's going to tell me that this particular velocity has a mean of 0.3183 meters per second. Okay, let's do the bottom. This is after the collision. You know it changed direction, right? So we should expect that, because it's going backwards, to end up being negative. So here you can see that one is negative 0.367. Oh, sorry, that's the mean, the minimum. Here's the mean. Negative 0.3452 meters per second. Okay? So it looks like it bounced back a little bit faster. Wonder why that is. Okay, so now what I'm going to do is I'm going to switch over to my template that you should find in the assignment. I'm going to say, we're going to fill this in now. So we have the mass of the car, and you have to determine this yourself. It was 0.251 kilograms. It was 251 kilograms. And if I go back, my velocity before was 0.3183. So I fill that one in, 0.3183. And then object after, it was the object A was still 0.251, didn't change. But now the velocity became negative 0.3452. So I'm going to say negative 0.3452. Now you can see that it has shown me now the momentum here. Momentum is mass times velocity. It's abbreviated with a P. And before, we had a momentum of 0.08 kilogram meters per second. After, it had a momentum of negative 0.087, right? And remember, there's a little note there. Remember that the momentum in the opposite direction is negative. Now let's do the B, the other side. So now we have that one sorted out. What I want to do is I'm going to add another point series with this button. And that's going to give me the space where I can do the other car. So I'm going to bring this back over here. All right, and I'm going to do the same thing. So, so now I'm going to, I've already set my scale, I've already got my axis, and I'm going to start doing this. So now I got to find a good reference point on this car. Let's do that bottom front corner. Okay, so click, click, and notice the dots are red. It's differentiating the two. They are going to pile up on top of each other, but you know, don't worry about that. All right, here we go. Here they come, about to wipe each other. Bam, and back. Now you see it is really not going back, this one. This one is still going forward, very slightly. What does that tell you? That tells me that the one on the right just trucked the one on the left. Okay, that's probably enough. All right, so this one actually continued forward but slower. Okay, so now this one now is trying to show me the same distance measurements. So I'm going to change those to be x velocity 2. Okay, and now I'm seeing something different. So now I'm seeing that it was going at this velocity here negative because it's going in that direction towards the, the axis. It was going negative to begin with. And so I can now do my same stats work, and I can collect those bits there, let's say, and I can do stats on that one. There we go. You can see it was going negative 0.3015. And then I can do this. Bam. See how easy this is? And it is now negative 0.07198. Well, you're going to see why that happened. Check this out. Okay, so this, let's switch back to our spreadsheet. The second object, object B, has 500 grams extra mass on it. So it is 0.751 for both of these. but the velocities are different. So the first velocity was negative 0.3015. Negative 0.3015. And then the after was negative 0.0719. Let's call it 0.072 because that's rounded numbers. Okay? All right. Now, look what we've got here now. The whole thing is filled in. And what I found now is I've got the momentums before and after, and now what this has done automatically for me is combined. It's literally added this momentum to this momentum. Okay? It had initially a negative momentum combined because the big heavy one was going in the negative direction. Afterwards, you can see this is the momentum of the first object, the second object, and now there's a I messed that up, didn't I? It was still negative. Sorry. There. Negative. Okay, now it's got a combined momentum after of 0.141, and you can see that there was a difference. There should be no difference in a perfect world, but we don't live in a perfect world, children. So we lose energy, we lose momentum due to friction, due to deformation of the plastic, due to sound production, etc. And so this is what was lost. We lost 0.006 kilogram meters per second. Whoop-de-doo. Okay, but this is what you would turn in then. This would show before and after. And you should also turn in this file. You don't just turn in a screenshot. You're going to turn in the whole file. So you're going to save as, and it should be a CMBL file. I wouldn't save it in the sample movies. Save it on your desktop or whatever. Give it a name. It's going to be a CMBL file, and it will include this video in it, hopefully. That works. Okay? I don't remember if it did with the other one. Okay? That's a long video. I apologize for the length, but I hope that tells you how you're going to do it. If you do it with some other videos, you might have to make some assumptions about these masses, because I've told you the masses of this and this. If you just show, two, billy goats hitting each other, then you might have to make a guess about the weight of one of the billy goats, but then you could even solve for the mass of the other billy goat. There's a lot of cool stuff you can do with this. Have fun with it.